Hi, welcome to Coding Droplets and thank you for watching this video. This is a complete course to develop .NET applications or services with gRPC. So this video is part of a series and this is the third video of the gRPC C# tutorial series. You can check out the playlist link that is mentioned in the video description for finding the other videos in this series. In the previous videos, we have already covered the basic concepts of gRPC, protocol buffers, which is also called as protobuf, then data types in protobuf, gRPC, unary API, etc. Now in this video, we are going to see about the gRPC streaming APIs. gRPC streaming APIs are the APIs with which we can stream data. Streaming data means we can send multiple or infinite data without any limitations using a single TCP connection. Streaming data is a highlighted benefit of gRPC APIs. As you know, this option is not there in very commonly used REST APIs. gRPC streaming APIs are one of the best options if you are dealing with big data. There are three types of gRPC streaming APIs. The first one is gRPC server streaming, or it is also called as server streaming RPC. So RPC means remote procedure call. Now the second type is gRPC client streaming. It is also called as client streaming RPC. Now the third one is gRPC bidirectional streaming. It is also called as bidirectional streaming RPC. Now let us see one by one. We'll be discussing in detail about each and implementing all the three in a demo C# project. Don't miss the upcoming videos in this channel. Please subscribe the channel named Coding Droplets. Also don't forget to press the bell icon so that you will get notified once we upload new videos. First, let's have a look on gRPC server streaming or server streaming RPC. A server streaming RPC is like a unary RPC, which we have already discussed in the previous video, except that the server returns a stream of messages in response to a client's request. So the client can send a single request to the server, that is what we have discussed in unary RPC. The client will send a single request to the server, but in unary RPC, the server will send back a single response. But the difference is here in gRPC server streaming or server streaming RPC, the server will respond back with multiple or a stream of messages. So let's see how it is. So I have created a new solution in Visual Studio. You can see there is a solution named gRPC Streaming API Demo. Under that solution, there are two different projects. One is gRPC Server. So this is the gRPC API service which we will be creating for streaming the data. And I also have created gRPC Client. This is a console application which we will be using for consuming the gRPC API. So the client application can be any kind of applications. It can be web application, console application, or whatever kind of application. Now for showing the demo, I'm just using a console application. So now let me open the streamdemo.proto file. So we will be using this proto file to create the streaming APIs. First, let me create a message. So this will be the message for passing data in request and response. So I'm not going much in detail about the message part, as we have already discussed those details in our previous video. So here we are creating a very simple message that we can pass a string as a request and response. So let me create a sample or let me name it as test, message test. So here the data type will be string and the field name will be test message equals 1. The field number, let it be 1. Now we are creating a service RPC, and the name of this service is server streaming demo. So this will be the method which we are going to call from the client. So this is the method name, server streaming demo, and this method will accept test as parameter. So along with the request, we have to pass test, and it returns same test as response. So in the response, it will return test, but here there's a small difference. We know that in normal unary API, we used to provide it like this, as we need to send one single request and we are getting, or the server will return back a single response. But here in server streaming API, we need the server to send multiple responses. So what we need here is the server should be able to send multiple test messages. That means multiple instances, or it is not an array. The server will send this response multiple times. So for that, what we have to do here is we have to use stream keyword, stream test. So now the server will be able to send a stream, and all the response will be of format, or will be this test message. So I will show you how it is. Now we have to implement this method in our service. So for that, I'm opening Solution Explorer, and you can see we have a folder named Services. Inside Services, we have Stream Demo Service class here. So now there is nothing inside this class. So as we discussed in the previous video, we can override the method which we have mentioned in the protobuf file. So I'm doing that, and you can see now we have a method public override task server streaming demo, and we are getting the parameter test. This is the request which we are passing along with this method from the client. So we will get the request here. Now we are going to implement this method here. So the first thing what I'm going to change here is I need to make this function asynchronous. So this will be async task. Now here I am creating a for loop for int I equals 1, then I less than or equal to some 20, then I plus plus, sorry, fine. Now what I need to do here is I need to send some 20 messages to the client. So what we can do here is await response stream dot write async. So response stream is an object which we have got here in the parameter, so we can make use of that object here. Write async. Now here we can send message. So I'm sending a message, then whatever value we have in I, let it be there. Oh, sorry, we cannot send it like this. First we need to use new test. Test is the type of data which we need to send as response. So new test, and here we have test message, and the value for this test message will be this message space, then whatever value we have in this I variable. Fine. So now this is enough for showing the demo of a server streaming API, but I need to show you some more details about this. So what I'm doing here is I'm creating a private random object, random. Okay, you don't need to create this. This is only for showing you the demo to make you understand how this function works. So public, I'm just creating a constructor here, stream demo service. Now random equals new random. Now here I'm creating a random number. So the random number will be from 1 to 10. Okay. So while this for loop works, each time it will create new random number. So the minimum value will be 1 and maximum value will be 10. So it can be 2, 3, 4, 5, whatever it may be. We don't know what the value will be. It will be random numbers. And here I'm doing one more thing. Await task dot delay of random number. So I'm just delaying this for loop. So once we send this write async, or once we send this particular message to the client, then this here the server this method will get delayed for some seconds. That is what I need. But here actually task.delay will accept values in milliseconds. So if we need to make it to seconds, we need to multiply it with 1000. Now if the value of random number is 2, then here it will wait for 2 seconds, then only again this will work. The first method, the write async method will work. Then again it will wait for another some seconds, few seconds, and again the next method will work. So in that way it will send a stream of data. So this is the server implementation for server streaming demo. Now I will show you how we can implement or how we can consume this API in a client project. So again, I am telling you this task.delay method is implemented for showing you, like for example, this API is doing some bigger tasks and it is taking some time. So now for showing the demo, instead of doing bigger tasks, what I am doing here is just delaying it for few seconds. Fine, now let's do the implementation in the client project. For that, I have opened Solution Explorer, and first thing what we need to do here is I need to copy the content from streamdemo.proto file, and I'm going to the protos folder, and here also we have a proto file, and I'm just replacing this with the new content. And now if I compile the project, the gRPC service or gRPC library will create the code for implementing this client client call. So now I'm going to program.cs, and now I'm doing the implementation here in the void static void main method. So here let me create a new method, private static void server streaming demo, and let me call this method from the void main function. Yeah. Now in this method we are going to implement server streaming demo. So here what we need to do here is, first we need to create a channel, or channel equals gRPC channel. So for that we have to use gRPC .NET .client, and here we have to give the base URL, sorry, not like this, so channel.from address, and here we have to provide the base address of gRPC service. So let us see what is the base address coming. I'm just running this application, and let us see what is the base address which the service is listening to. Okay, here we can see the base address is HTTP localhost port number 5043. So I'm closing this application and pasting it here. Fine. Now the next thing is var client. We have to create the client, new stream demo dot stream demo client of channel. Fine. Now we have created the object for the client. Now the next thing is var response. Now we can directly call the method from the client. We can call the method using this client object. So we can see here we have server streaming demo. This is the method we have to call. So to this we have to pass a request. So test message equals test. We can provide whatever value we need. Anyway, we are not using it. We are not using this value in our server as well. This is just for a demo purpose. Now here we can use a while loop while response stream dot move next, and here we have to pass a cancellation token. If you have a cancellation token, you can pass it. Otherwise, I'm not using cancellation token, so I can pass cancellation token dot none. Fine. Now here it is showing in red color. Why? Because this can be awaited. So here I'm making some changes. Private async, I'm making this as async method, and private async task. Fine. Now I can await response stream dot move next. So now this move next method will return a boolean value, true or false. So if this is true, that means there is a response coming from the server. So here also we need to make some changes. I'm making this static async task, and I'm awaiting this method. Okay, this should be static. Fine. Private static async task. Now what we can do next is var value. So we are just reading the value to a variable response stream dot current. So this current will be of type test. Now we need test dot test message. We are having a property or a field named test message. So in this field we will get the data. So I'm just saving it to a variable named value. Now I'm just writing to the console window console.writeLine value. Fine. And after this while loop, I'm just printing console.writeLine here server streaming completed, and here do one thing, channel dot shutdown async. I can await this. Fine. Channel dot shutdown async. After completing this API call, I can shut down this channel as we don't need it anymore. Fine. Now let us run this application and check whether it is working as we expected. So first let me run the server application. Okay, the server application is running now. It is HTTP 5043. I think that is the same we have mentioned. Yeah, 5043. Fine. Now let me run the client application. Debug, start new instance. And here now you can see that we have received message 1. So the server application is running here. Message 2. So in every for each method we are delaying the message for some few seconds. So that is why it is taking some time to show the next message. So I'm just fast forwarding the video here, otherwise it will take a lot of time to complete 20 messages. So let us wait for the final message. 20. Now again there is a delay, and now you can see server streaming completed. So this is the message what we are displaying once this while loop or once the move next method is false. So once it is false, the application or it will exit from this while loop and go to the next line, server streaming completed, and the channel will get shut down. So here we can see in the client console window, after receiving the whole 20 messages, it has printed server streaming completed. So this is how server streaming works. Next, let's have a look on gRPC client streaming, which is also called as client streaming RPC. So in a client streaming RPC, the client will send multiple messages or a stream of messages to the server, but the server will respond back with a single message. So now let's implement a client streaming API in our C# project. So let me open the proto file of our gRPC service. So stream demo.proto. Now here we can implement client streaming API. So RPC client streaming demo. So this will be the method, and here we will use stream test. So the client will send a stream of messages or multiple messages of type test, and the server will return a single message. So that is also type of test. So this can be any type. If you need, you can create another message type and it can be returned. So now for showing the demo, I'm just using the same message type here. Fine. Now let us implement client streaming demo in our service. So I'm going to stream demo service, and let me override the method. So here you can see now client streaming demo. Fine. So first I'm making this method async. So this will be asynchronous, and now here I can use while loop, and here I can await the request stream. We will get it as parameter here. Request stream dot move next. Here we don't need to pass the cancellation token to the move next. So request stream dot move next, that is enough. Now here what I'm doing here is console dot write line request stream dot current dot test message. Okay, so current will be of type test, and inside this test we will be having test message which we are sending from the client application. So we will be printing all the messages in the console window of the server application, gRPC ASP.NET Core server application. And once it is completed, we will again write on the console window, that is console.writeLine client streaming completed. Fine. After that, now we have to pass a new test message. So we will pass sample. Okay, so the client can read this message, and the server will only send a single test message, but the client will send multiple messages in the request. Now let us do the implementation in the client project. So let me close all the tabs and going to the client project and opening the program.cs class here. Now I'm creating another private static method, private static async task client stream demo or streaming demo. Fine. Now let me call this method from the main method. I'm just commenting the previous one. Fine. Now let us implement the method. So here we need the channel. I'm just copying it, and also we need the client, so I'm copying it. Fine. Now var response equals client, or instead of response I'll do var stream equals client dot client. Oh, sorry. In order to do that, first we need to update the proto file. So I'm copying the content of the proto file from the server application and copying it to the client application. Fine. Now we can just compile the client application so that gRPC will generate the code for us. Fine. The compilation got succeeded. Now I can use client streaming demo of new. Okay, here we don't need to pass anything. Fine. Now the next thing what I'm going to do here is for int I equals 1, I less than or equal to 10, I plus plus. Now I'm sending multiple messages to the server. So stream dot request stream dot write async, and here I can send the message. So message space and the value of I. Oh, sorry, we cannot send just a string. We have to send test. So new test, and here in test there will be a field named test message, and here we have to pass the value. Fine. Now write async can be awaited, so I am just providing await keyword here. Fine. Now once it is completed, now there is a small difference between a server streaming and client streaming. Now when we are doing client streaming, we have to notify the server that client streaming has been completed once we are done with the whole messages. So now after completing this for each loop, or after completing this for loop, we have to notify the server that the streaming has been completed. So for that, stream dot request stream dot complete async. So this will notify the server that the stream has been completed. And now I will just write completed client streaming in the console window. So now let us open the gRPC service. So just before that, I will show you the implementation of client streaming in the server side. So we are printing all the messages what we are receiving from the client, and once it is completed, we will print completed here in the server as well. So now I'm running the server, debug, start a new instance. Now let me run the client as well, debug, start a new instance. So here the server is running and here the client is running. So here you can see now immediately it got completed. So we can do one thing as we did before. We can create a random variable here, so, and we can make some delay on each method. So private random, and here I am initializing it, random equals new random. Oh, this should be static. Fine. Now here in the same way, I'm just copying it from the server implementation which we have did before. So after each for loop, or while executing this for loop, after each write async, I'll run this method, so it will delay for a few seconds. Now let me run both, debug, start new instance. Fine, the server is running. Now let me run the client project as well. Okay, both server and client are running now. Now we can see how it works. And the server received message 1 now after some delay. Now there will be some more delay for message 2. Yeah, message 2 has been received here in the server. message 3 has been received. So the server will receive the whole messages from the client, then only the function will complete the execution. So it will be inside the while loop which we have mentioned in the server side. So only after completing the whole messages from the client, it will exit from the while loop. Now let us wait for 10 messages. After 10 messages, the execution will get completed. Message 7, message 8. Now 2 more messages has to be received. 9 and 10 will come now. 10. And now you can see it will show the message completed soon. Yeah, client streaming completed. So once this particular function executed, stream.requestStream.complete async, then the server will exit from the while loop and it will go to the next line, client streaming completed. So this is how we can implement client streaming. Next, we are going to have a look on gRPC bidirectional streaming, or it is also called as bidirectional streaming RPC. In bidirectional streaming RPC, both client and the server can send multiple messages. That means both request and response will be a stream of messages. To understand bidirectional streaming RPC in a better way, I will be implementing parallel tasks in our C# demo project. So the main point which I need to explain here is, here the server and the client will communicate each other on a single TCP connection completely parallelly. That means it will be completely asynchronous. The client might send 1 or 2 messages to the server and the server might respond 1 message, and again the client will send 3 or 4 messages and the server will send 2-3 responses back. So in that way the communication will be completely asynchronous, and I will show you how we can implement that in our C# demo project. So now let me open the proto file in our gRPC server application, and here I'm creating a new method, RPC bidirectional streaming demo, and here the request should be a stream of message, so stream test, and it returns stream test again. So both will be streams. Request is also a stream and response is also a stream. Now another point which I need to mention here is this, you can see here both request and response are of test. So it is not mandatory that we have to use same type of objects or same type of messages in response and request. We can use different types of messages, but here I'm just showing you how the streaming functionality works in gRPC. So I'm using a single message object for all the methods. Now let us implement the bidirectional streaming demo method in our service. So I'm opening stream demo service, and here I am overriding the method here, override, and here you can see bidirectional streaming demo. I'm just declaring a variable named tasks, which is a list of tasks. Okay, I will explain you why we need this. This is just for showing the demo. And now here, as we implemented before, while here we are listening for the response, not for the response, the request from the client. So await request stream dot move next, and here let's assume we are doing some tasks here in the while loop after receiving each message from the client. So let me make this asynchronous, async task of bidirectional streaming demo. Fine. Now once we receive a message, what I'm doing here is I'm writing in the console window console.writeLine, and here I'm just received I'm just typing a message received request, and here it will show request stream.current.test message. Fine. Now after this, I'm creating a new task and adding it to, okay, I'll do one thing, var task equals new, sorry, task dot run. So I'm creating multiple tasks when we execute this while loop. So when each message received from the server, a new task will be created. And in this task, let us assume we are doing some functionalities or some time-taking processes. So here what I'm doing here is, as we did before, I'm just generating a random number and just delaying the task. Okay. Before that, we have to make this async first. That is one thing. Now, before that, var message equals request stream.current.test message. Okay. Now, once this function is delayed and once it completed this much of time, we are going to response stream. So response stream we will get as a parameter here. So response stream dot write async, and here we are sending a message. We are sending the same message what we are receiving. So what I'll do here is request, not request, we are getting, okay, here we are saving it in message variable. So new test, and the test message equals message. Okay, and here this can be awaited, so I'm providing the await keyword here. Now after this, I'm just writing on the console window, console.writeLine sent response plus message. Fine. So we will be showing this message has been sent back as a response. Fine. So after this while loop, now here what we are doing here is task dot when all tasks. So what this function will do here is, I'll explain it, await. So I'm just providing await keyword here. Now what this will do here is, now after completing this while loop, it will wait for all the tasks in this task list to be completed. So if this while loop is running 10 times, it will create 10 different tasks in this task list, and the server will wait here for the whole 10 tasks to get completed. Then only it will move to the next line. And after that, I am writing here console.writeLine bidirectional streaming completed. Fine. So this is the server implementation. Now let us implement the same bidirectional streaming API in the client project. Just before that, I forgot one thing here. So now we have created a task here. So now the next what we have to do here is tasks.add task. Then only this particular task will be added to the list. And once all the tasks are added, it will wait for all the tasks to get completed here. So then only it will go to the next line. Fine. Now let us move to client implementation. So let me close all the tabs and moving to the client project, and in program.cs I am creating one more private static method, private static async task bidirectional streaming demo. Fine. Now here let me call this method here from the static void function await bidirectional demo, and let me comment this client streaming demo file. Now here I am using two different tasks. One task is for sending the data to the server, and another task is for receiving the response from the server. So we will be running both these tasks parallelly at the same time. So let's implement that. So var request task equals task dot run. Okay, now here we need one more task. Response task equals task dot run, and here we will await for task dot when all request task and response task. So here the application will wait for these two tasks to get completed. So now let's implement the tasks now. So in request tasks, what we need to do here is for int I equals 1, I less than 10, less than or equal to 10, fine. Now, okay, just before that, we need the channel and the client. So I'm just copying these two. Fine. Now var stream equals client dot bidirectional. Okay, so in order to implement that, we need the proto file to be updated. So I'm just copying the proto file content from the server application and pasting it here in the client project. Now just compile the project so that gRPC will generate the code for us. Okay, the build got succeeded. Now I'll be able to use client.bidirectional streaming demo. Fine. Now here stream dot request stream dot write async new test, and the test message equals I. So here I is an integer, so we need to convert it to string. We are just passing the number as string. Fine. So after completing this for loop, we will tell the stream dot request stream dot complete async. So this will inform the server that the stream has been completed from the client side. So in order to await it here, we need to make this an async method. Okay, and this also can be awaited. So let me provide await keyword here. And so this is the implementation for the request. Now let's implement response here. Okay, just before that, I think we can provide the same kind of random number delay. So I'm just implementing the same here. For random number random.next. Okay, it will delay for a few seconds. Now the response. So have we done? Okay, one moment. Let me check the server implementation. So here in server bidirectional demo, okay, we have implemented the delay here. Okay, I just need to check whether we have implemented this. Fine, that is implemented. So now in response task, what I'm doing here is, okay, just before that, now after completing write async, I'm just printing here console.writeLine send request I. Okay, so it will tell us we have sent this number now, sent the request. Now response, here what we are going to do here is while stream dot response stream dot move next, and here we can use cancellation token. So I'm just using cancellation token dot none. and this can be await, and we have to make this task function async. Fine. Now while we are receiving a message from the server, that means we are receiving a response from the server. So what we are doing here is console.writeLine received response. So here we can use stream.response stream.current.test message. Fine. Now once this is completed, we will just print console.writeLine response stream completed. Okay, fine. I think now the implementation is done. Now let us run the application and test it. So first I'm running the service application. Debug, start new instance. Okay, the server application is running here and it is listening. Now let me run the client application. Debug, start new instance, and client application and server application is running, so we can see the data here. So now we can see this, it has sent and immediately it got received here, and service responded back, received here 1, 2 and 3 sent immediately, and here it got received, sent 2. So here you can understand now this is completely parallel, means it is not like sending one request and getting the response back for that, and sending another request and getting back the response for that. So it is not like that. It is completely parallel or completely asynchronous. So the client will send 1 or 2 messages, or we can make it how many messages, like sending 100 messages, and the server will respond back with 1. And again the client will send some 10 messages, then server will respond back with some 20 responses. In that way it will be completely parallel. And once everything is completed, you can see here bidirectional streaming completed, and here also the client, it is showing response stream completed. So this is how we can consume a bidirectional API. And here I forgot to do one thing. So once all the tasks are completed, we have to mention channel.shutdown async. So then only the TCP connection will get closed once the consumption of the gRPC API is completed. So here I forgot to mention that. So you have to make sure that you use, or you have to call this method shutdown async to close the TCP connection. So in our client streaming demo as well, we have not given that. So once everything is completed, then we have to pass, or we have to call channel.shutdown async method. This can be awaited, and here we have given server streaming demo we have given. So for bidirectional and client streaming we have not given that. We have to give that in order to close the TCP connection. So that's it for this video. Now we have seen how we can implement gRPC streaming API. So there are 3 types of APIs: server streaming, client streaming, and bidirectional streaming. So we have implemented all the 3 in our C# demo project, and also we have consumed all the 3 APIs using a client application. So hope you are clear with the points, and please give me a thumbs up for this video if you liked it. Please share your feedback in comments, and thank you all. See you in the next video.